Hi friends, welcome back. Today we're talking about congruent chords in circles. So grab your notebook, you're going to want to write this one down because this is a theorem. If we have two chords that are congruent, then their arcs are also congruent. And the converse, if we have two arcs that are congruent, then the chords that attach those are also congruent. So pause the video, write that down. Now why? Why are you might be asking yourself, well, if you take a look here, you'll see that I have drawn in green these going from the center out to the circle. Those are called radii, right? So I have 4 radii here. 1, 2, 3, 4. And no matter where a radius is on a circle, they're all going to be the same. They're going to be congruent. So this guy is congruent to this guy, which is congruent to this, which is congruent to this. Now I've already told you that these guys are, well, let's back up. If you see that opening, if these two things are congruent, like this is congruent to this guy right here, remember central angles, that means those arcs have to be the same because we know that they're going to be opening to the same length. These triangles are congruent by side, side, side. So hopefully that makes a little bit of sense, but you can kind of see if we draw in these radii, then that's why it looks like this. So, all right, so let's put that into the test, right? Put that to the test. I can't talk today, I'm sorry. All right, so we have this first one here that looks like this. It's, we're given a circle, we are given 2 chords, and we are told that those chords are congruent, therefore the arcs are also congruent. Remember, we never assume anything in geometry. So because these 2 chords are congruent, then the arcs are congruent, and all I have to do is say 2x plus 11 equals 94 and solve that equation. If I do that, if I've got, so minus 11 minus 11, I get 2x equals 83. 83. So if we do let me pause this just for 1 second. Okay, my apologies on this. I copied this down wrong. This is supposed to be 47 right here, 47 degrees. And so that would make this 47 degrees. So that would make this guy 36 degrees. Okay, that makes more sense now. So my apologies on that. If we divide this by 2, we divide this by 2, we get x equals 18. And we are looking, we always go back and read the question. It says find x, and we found x. That gave us 18 here. So that means that this arc is 47 degrees. This one is also 47 degrees. And if we plug 18 into here, we would have 18 times 2, which gives us 36. Plus 11, which would also give us 47 degrees. So sorry about that. The next one that we have is example number 2 here. This says find the measure of arc AB. Find the measure of arc AB. Okay, so we are told that this major arc here, because it's over 180 degrees. This is kind of an oval shape, sorry. Can't draw circles. But this is I draw them so that you know what to draw in your notebook as opposed to just like printing out beautiful looking circles. So this is 622 degrees, which means because these two things, we are told these are congruent, these chords are congruent, then the arcs are also congruent. So this is also, this guy right here is also 5x minus 11 degrees. So we can go about this a couple of ways. What we can say is 2 times 5x minus 11, because there's 2 of them, plus 262 equals 360, because this plus this is all going to give us that full circle of 360. So if we minus 262 from both sides, we end up with 2 times quantity 5x minus 11 equals 98 degrees. 98 degrees there. Now, so what that's saying is we have 360 minus 262 means that we have 98 degrees, and we've got to cut that evenly in half because each half goes to this. So if I divide those by 2, I get 49. So each one of these equals 5x minus 11 equals 49 degrees. So from here now we can solve that. Add 11 to both sides. We get 5x equals 60 degrees. Divide both sides by 5. We get x equals 12. Go back, reread the question. It says, find the measure of arc AB. Ah, okay, well, we found x, but we haven't found the measure of arc AB. Remember, the measure of arc AB is the same as the measure of arc BC, so 5x minus 11. 5x minus 11. Now, we know x is 12, so we're going to plug a 12 into there. Minus 11, so we get 60 minus 11, which gives us, we're right back at that 49. So the measure of arc AB equals 49 degrees. We actually didn't need that 5x minus 11 because I showed you we took 360, we minused this, and we were left with 98. Divide that by 2, we get 49 degrees. But I just wanted you to see how that worked out. Okay, let's look at example number 3 here. This time we are told that the arcs are congruent. Therefore, the chords are congruent. So we are going to, since the arcs are congruent, the chords are congruent, we can just set it equal to each other. So we're going to say 11x minus 39 equals 6x minus 4. I like to deal with my variables first by moving them to the left. Minus 6x minus 6x. At the same time, I'm going to add 39, so plus 39. So this will give me 5x equals 35. Divide both sides by 5. I get x equals 7. Now we go back, reread the question. It says find chord TU or segment TU. I've only found x so far, so I have to go find TU. So TU is 6x minus 4, and we know x is 7. So 6 times 7 minus 4. So it's 42 minus 4. That would give us 38. So the measure of chord TU is 38 units. So hopefully that helped. If you have any questions, leave them below. Otherwise, we'll see you next time.